Assalamu alaikum everyone. This is Fahad Ansari and I'm here to help you conquer chemistry. In the previous video, we looked at moles and how to convert between moles, mass, and number of particles. So in case you didn't watch that, please watch it right now before we move on with this video. In this video, we will be looking at reacting masses. We'll be looking at chemical equations, something that look like this. Basically, these are equations that involve reactants on one side, substances that will react to form new substances, which are known as products. So in this equation, you can see that in front of the formula of each substance, like carbon over here, you have this number 2. In front of carbon monoxide, you have this 2 as well. And in front of oxygen, you have no number, so that automatically means that this is going to be a 1 over here, right? So these numbers in front of each formula, these are known as coefficients, or the more technical and fancy term for this is the stoichiometric coefficient. And this basically tells us the number of moles of each reactant and product. So for example, over here we have 2 moles of carbon that reacts with 1 mole of oxygen, and these will give you 2 moles of carbon monoxide. So if we want to convert that into masses, then 2 moles of carbon, we know that carbon exists as single atoms. So for that, the molar mass will be equal to the AR, or relative atomic mass of carbon. So if you look at the periodic table, we have carbon over here with a mass number of 12. And oxygen has a mass number of 16, which we will also use. So 2 moles of carbon means that we have 2 times the molar mass, which is 12, the AR in grams. This gives you 24 grams of carbon. 24 grams of carbon that will react with 1 mole of oxygen. So 1 mole will be multiplied by the molar mass of oxygen. Now oxygen exists as molecules with 2 oxygen atoms each. So this will be 1 times the molecular mass of oxygen, which is 2 atoms of oxygen, times the atomic mass, which is 16. And so that becomes 32 grams of oxygen. And then we have the product, carbon monoxide. We have 2 moles of this, right? So 2 moles will be multiplied by the molecular mass of carbon monoxide. So molecular mass is basically the sum of the ARs of the elements within the formula of that molecule. So this is going to be 12 plus 16, and that will give me 56 grams. All right. And notice how this mass of carbon 24 plus this mass of oxygen 32, these 2 masses of reactants will add up to give you the mass of the product, 56. So 24 plus 32 gives me 56. So this sum over here is not by coincidence. This actually refers to the law of conservation of mass, right? And this basically states that matter cannot be created nor destroyed in a chemical reaction. The total mass of all reactants equals the total mass of all products in a reaction, right? But we cannot say the same about moles, because if you add up moles of reactants, that actually gives you 2 moles of carbon plus 1 mole of oxygen. That's 2 plus 1, and 2 moles of carbon monoxide, which is 2. So these 2 are not equal to each other, right? So it does not work for moles, but it does work for mass. The total mass of reactants equals total mass of products. So that's the law of conservation of mass. Now we could use this information to balance equations, right? So let's say we have been given an equation like this. 4 grams of hydrogen gas react with 32 grams of oxygen gas to produce water. So what we could do is find the number of moles of each, right? So hydrogen exists as H2, right? So its MR is going to be 2 times 1, right? So MR is going to be 2 atoms of hydrogen times 1, the atomic mass of hydrogen, that gives me 2. And 32 grams of oxygen, so oxygen exists as O2, so its MR is going to be 2 atoms of oxygen times 16, the AR, which is going to be 32. Then, in order to convert these masses into moles, we divide by the MR, right? So, moles of hydrogen, we could write moles of hydrogen will be 4 grams divided by 2 grams per mole. So that's the mass of hydrogen divided by the molar mass. Grams and grams cancel, and this becomes 2 moles. And moles of oxygen will be 32 grams divided by the molar mass, which you just found, which is also 32 grams per mole of oxygen molecules. So this becomes 1 mole. So now we will add this up, right? So we will write 2 moles of hydrogen plus 1 mole of oxygen. We don't need to write the 1 as the stoichiometric coefficient. This will give me water. The formula of water is H2O, right? And law of conservation of mass states that 4 grams of hydrogen plus 32 grams of oxygen should give me 36 grams of water, right? And we know that the MR of water is going to be 2 times 1 plus 16, that is 18. So when I divide the mass by the MR in grams, which is the molar mass, then I'm going to get 2 moles. So I write it 2 over here. So now, if you count the atoms, we have 4 hydrogen atoms over here, 4 hydrogens on the left-hand side, we have 4 hydrogens on the right-hand side, 2 oxygens on the left-hand side, and 2 oxygens on the right-hand side. So number of atoms of each element in this equation are equal, and so this equation is balanced thanks to the law of conservation of mass that looks something like this, right? A long time ago, the mass of the TV used to be greater, but now it has lost mass, whereas the TV owner has gained mass. So total mass is still the same. No mass has been created or destroyed. All right, so now on to the concept of limiting an excess reactant. So let's say we have this equation over here, right? And let's say that we have 32 grams of methane. This formula is given over here. And we have 160 grams of oxygen. So we want to make these products. Now we want to know whether either of these is going to react completely or some will be left over. So what we're going to do is, first we find the MR of methane. It's going to be 16, right? 12 plus 4 times 1. So that's going to be 16 grams per mole. So we have 2 moles of methane, right? On the other hand, oxygen, we divide this by 32 grams per mole, which is the molar mass of oxygen. 2 times 16 is going to give me 5 moles of oxygen, right? Now, the molar ratio of these two substances, these two reactants, is basically 1 mole of methane to 2 moles of oxygen, right? So it is a 1 to 2 molar ratio, right? But over here, with the masses given, we get a 2 to 5 molar ratio, right? If we were to respect this 1 to 2 molar ratio given in the equation, then if we have 2 moles of CH4, it should be reacting with 4 moles of O2, but we have 5 moles of O2. That's more than what we require. So oxygen in this case becomes our excess reactant. We have more oxygen than what we need, right? We have 5 moles of oxygen when we actually required 4 according to the ratio of the coefficients, this 1 to 2 molar ratio, right? And if we were to look at it the other way, let's say we had 5 moles of oxygen, then according to this 1 to 2 molar ratio, we would simply divide 5 by 2 to get 2.5, right? Just like we divide 2 by 2 to get 1, we divide 5 by 2 to get 2.5. So if we have 5 moles of oxygen and they were to react completely, then we will only need 2.5 moles of methane, but we only have 2. We have less moles of methane than what we require for all of the oxygen to completely react, so methane becomes our limiting reactant. And the importance of the limiting reactant is that the number of moles and the mass of each product will be defined by the moles of limiting reactant, right? So you have 2 moles of CH4. So now we're going to look at molar ratios. So methane over here is CH4, right? So we have 1 mole of CH4, and that is going to produce 1 mole of carbon dioxide, right? So this is a 1 to 1 molar ratio. So if you have 2 moles of methane over here, that should give us 2 moles of carbon dioxide, right? And then from methane, the limiting reactant, once again, we have a 1 to 2 molar ratio with water, right? So if we have 2 moles of methane, we should get 4 moles of water, right? I mean, we had the 1 to 2 molar ratio, so if we have 2 moles of methane, we should get X moles of water. We just cross multiply, X becomes 4 in this case, right? So we have 2 moles of carbon dioxide, 4 moles of water, right? And we will have some oxygen left over. That's the excess reactant. So what we will do is, remember, from the limiting reactant, 2 moles of it, only 4 moles of oxygen will react. But you have 5, right? You have 5 moles of oxygen, so you will subtract from 5 the actual moles you have. You will subtract the moles that actually react, so you'll get 1 mole of oxygen. And this is the 1 mole of oxygen in excess. So if we count the moles of all that is left at the end, we have 1 mole of the excess reactant, and we're going to add to it the 2 moles of carbon dioxide and the 4 moles of water. That's going to give us 7 moles of substances left over at the end. So this is 1 mole of oxygen in excess. This is 2 moles of carbon dioxide and 4 moles of water that were all made thanks to the 2 moles of methane, the limiting reactant, that defines the amount of product that is made. All right, so enough for this video. Inshallah, in the next video, we will look further at some molar concepts. So if you like this video, don't forget to like, share, and subscribe to Conquer Chemistry. And inshallah, I will see you in the next video.